Okay. Yeah, good morning. Welcome back to class. This is Mr. Brain. Yeah, this is, trying to solve questions under a particular topic that is expected to come out from your JAM exam. Okay, if you look very well, you can see that this topic is under atomic physics. Okay, so I have 8 questions. All right, they are all multiple choice questions, and I intend to solve all 8 of them. So pay attention clearly. If you need to go over the video again, pause and play, then you go over it again, depending on how fast you can understand. Okay, but I believe that at once you understand this. Okay, so I have 8 questions. At this junction, you can pause the video so that you can take note of all the questions, pen it down so that you can also do the calculation yourself. Alright? So now let's start. The first question, the number of photoelectrons emitted from the metal surface depends on that's the first question. The number of what? Photoelectrons. This topic is all about what we call photoelectric effect. What is photoelectric effect? It is the phenomenon, alright, that covers the fact that as soon as light strikes the surface of some metal, not all metal, alright, if light struck the surface of some metal, alright, what will happen? They will emit electrons. We have what we call thermionic emission, two of us. We have thermionic emission, right? So that thermionic emission is when the surface of the metal is heated red hot, or even white hot. Once it's heated like that, are you getting it? It begins to emit electrons at the surface, right? Thermionic emission. But in this phenomenon, it is what we call photoelectric effect. It is the thing behind your solar panel. So you see them outline just near a panel. What is happening? That panel is a photo collector. Photo means light. So if you collect light, are you getting it now? Alright? And electron will be emitted. Now these electrons are emitted in a field, electric field. So once the electron is emitted, it creates a circle which forms the current. Are you getting it? They are emitted in a potential field, electric potential field. Alright? Good. So that is what we call photoelectrons. Now there are some things you need to know which form the basis of all these questions. Why do they ask 1, 2, 3 questions? I will explain. Then you can now answer yourself. You judge for yourself, okay? Now we talked about photoelectron, right? Good. Not every light will emit electrons. As you can see that some of the calculators that use sunlight, right? Without battery, they use sunlight, but you discover that if there is no light, you now say, okay, this is really light. Let me use like torchlight. When you use the torchlight, the thing will fail you. It will come on, two of us. Not every light will emit electrons from the surface of this metal. Alright? So there is a light of a particular frequency that must emit electrons. Light is defined by frequency and wavelength. What I say? Light is defined by what? Frequency and wavelength. All the light have their different frequencies and different wavelengths. But they all have the same speed of light. In fact, all electromagnetic waves, I think, okay, not all of them, but all the light have the same speed. I would say, but they have different varying frequencies. Okay, so light is defined by the frequency. So what we are saying is that there is a particular frequency that a light must possess. And when I say a light, I'm talking of photon. The question could come in this form. What is a photon? Photon. Can you see the board? Let me write it. I don't know why blue matters. I'm becoming so stupid nowadays. Now, photon, right? Photon simply means a light of one wavelength. A light of what? A particular wavelength. Are you getting it now? Now, if you want to explain light further, you see, when you say white light is a combination of different colors of what? Light. You understand that now? So, when we just mention one light with a particular wavelength, one photon, that is what we are referring to, okay? So now, we have been able to say that the ability of electron or the propensity for electron to be ejected depends on the light that is coming. And that is dependent on what? The frequency of what? Light. Have you taken note of that? Right? Good. Now, the amount of electron that will be ejected is now dependent on the number of light that will be radiated, or the number of light that will be incident on this panel. Let's assume that this is a panel. You understand? So the amount of light that will be incident on this panel, alright, will now affect the number of electrons that will be ejected. So therefore, number of electrons ejected is directly proportional to what? When you're talking about amount of light, we're talking about intensity of light. So the number of electrons emitted is dependent on what? The intensity of what? Light. Remember, for electron to be ejected at all, that is dependent on the type of light. Frequency, right? But for a good number of electrons to be ejected means more light falls on the surface, right? So that is intensity. I hope you get that, right? Then also, now the whole phenomenon gives us an idea of what we call, an equation to do all these calculations, alright? Okay? So now we're talking about removing electron from the surface of the metal. True or false, So what is removing that electron? A light coming at it. So the light has its own energy. So let's say this is the please. Let me drop the marker. Alright. Let's say this is the energy of that light, of that photon. Okay? As soon as it comes, what will happen? Electron will be ejected. So there is an amount of energy that is used to eject that electron. Energy can never be created nor destroyed. For work to be done, for electron to be ejected, there is a work or amount of energy that was used to remove that what? Electron. Then as soon as the electron is ejected, then it will now move, right? If it comes out, it what? Move. So two work. First of all, come out. Overcome the binding force, then move. So this energy, the whole energy of overcoming the binding force and moving of the electron is dependent on this, right? So this one gave back to the first energy of coming out, then the energy of moving. Let's call it kinetic energy. Can you see that? Alright? Now the energy of ejecting is the most important thing. Let the electron come out first, right? So the energy of removing the electron is what we call work function. Work function. I get it. Work function. So that's the energy required. It's the minimal energy required by the what? The photon to emit electrons from the surface of a metal. So these are the expressions. Of course, energy in this level now. Energy has different forms, right? And all forms of energy have their different formulas, right? But what is common is that they all have the same dimension and they all have the same unit, which is joules. Now, at this atomic level, at this atomic level, the energy is what? What's the energy? The energy is what? Hf. What is H? Planck constant. Planck what? Constant. If we start talking about the story of how this equation came about, that will be story for another day. But let's do something very quickly that you understand. So, Planck constant times frequency of the photon gives the energy of what? That photon. Remember, what is photon? Light of one wavelength. Okay? Now, I've done a good work in explaining the whole topic in how many minutes? Let's answer this question now. Everyone, let's go. The first one. He said, the number of photoelectrons emitted from a metal surface depends on the intensity of the radiation, nature of the metal surface, source of radiation, duration of radiation. What is the answer? Intensity of radiation. Radiation is light, okay? Radiation, light, okay? So, now the next one. So this is our answer for the first one. You can see how easy it is. Now the next one. A beam of light falls on a metallic surface. The maximum kinetic energy of the photoelectron depends on the maximum kinetic energy of the photoelectron. What I mean by photoelectron is that the electron that have come out as a result of what? Photoelectric effect. Are you getting it now? So the maximum kinetic energy of the photoelectron depends on A. The area of the what? Metal surface, color of the light, intensity of the light, duration of exposure of the light, exposure to the light. So what is the correct answer to this question? What's the correct answer? Now, we are talking about this energy now. This is it. Energy of what? Photoelectron. Can you see that? Energy of what? Photoelectron. That is come out and start moving now. The energy that it possesses to move. All this energy, where is it coming from? Is it not this one? The light that brings the energy, right? Then it emits, right? What portion? Then what happens? It now moves, right? Kinetic energy. Good. So it depends on the light. So that is, it depends on what? Number one, frequency of the light, wavelength of the light, or energy of the light. So if you don't want to say energy, you say what? Frequency or wavelength. Remember, light is defined by what? Wavelength and frequency. I'm telling you, right? Good. So frequency of the light. Now guess what? When you say frequency or wavelength, another way of saying it is color. Does it make sense? Remember, every light is defined by what? There are different frequencies, right? The red frequency is different from what? Yellow frequency. The red wavelength is different from what? Yellow wavelength. Can you see? So if you don't measure frequency or what? Or wavelength, then they are also referred to what? Color. So which one is the answer? Color of the light. Can you see? Color of the light. That is what? Okay? Alright? So the question is, intensity of light. Oh, Mr. Brain, no, Mr. Brain, look at it now. Intensity. Intensity, that this is strong. No. Intensity has to do with the number of light that falls, not about the energy of the light. Are you getting it now? It's not about the energy of the light, it's about the number of light that is falling per unit area. You get it now? Are you getting it now? There are light of C. Light of very low frequency can have high intensity, that is, they are much, but they don't have enough what frequency to be able to emit. And remember, all that is or threshold frequency. Threshold what? Frequency. Threshold frequency is defined by this work, is the same as this work function. Work function is what? The energy required to emit the light. So threshold frequency is that the frequency what? Required, the maximum frequency or less the minimum frequency required for photo electron to be emitted. Alright, let's go back to the question. Number 3 now. The threshold, okay. Alright, the threshold frequency for photoelectric effect depends on this threshold frequency that will come out from here now. This one is a constant. So this threshold frequency depends on what? A. Frequency of incident light, intensity of incident light, potential difference between the cathode and the anode, wait, let me clean this one. Cathode and the what? Anode, there's a lot of shock, material or what? Photo cathode. So the frequency is dependent on what? The threshold, this threshold frequency that will be here. What does it depend on? Where is it coming from? Is the intensity of the incident light? I'm talking the intensity of incident light. That's the light. Incident, the word incident there means the light that is coming to cause the photoelectric effect. Are you getting me now? That light coming to cause the photoelectric effect, that's what we're talking about when we say incident, right? So, now the intensity of the incident light, I'm talking, even if you have high intensity or low intensity, is most likely not to have a what? High frequency. And remember, frequency is very important for the photoelectron to be ejected and to also move. Two of us. Two of us. Are you with me? So, now, it is what? Frequency of what? Incident light. So the frequency of the light, no. The light that will be coming, the frequency, if the frequency is high, it means that the energy is high. Are you getting me now? Not intensity. You understand now? So frequency of the what? Incident light. So you understand? Alright, so the next one, 4. A metal having a work function of calculation don't come now. So let's leave the board there so that I can do calculation here. A metal having a work function of 5.76 electron volt, please. Electron what? Volt is eliminated with a radiation of 7.88 electron volt. The kinetic energy of the photoelectron emitted from the metal surface is now Look at this question very well. They are telling you that the metal, remember, we are saying when light strikes something from the metal, electron will be emitted, right? So we're now saying that this metal, before any electron is coming out at all, it must, the work that must be done on it to emit that electron is what? Is what? 5.76 electron volt. That's the meaning of the work function of the metal. Do you understand? Alright, so you can go and write it there. Work function of metal is what? 5.76 electron volt. Now, then this metal was eliminated by a higher energy, which is what? The work of the light or photon. Let me put it. Work of the photon is what? 7.88 electron volt. Now the kinetic energy is, we already know that after the light is eliminated on the surface of the metal, it will eject the electron, work function, then it will now move. Kinetic energy, true of course, right? The electron will now move. So this is what we are looking for. That's what we are asking you to look for. The kinetic energy of what? The emitted electron from the surface of the metal is. So let's use our Hamilton formula. This implies that what? Ke is equal to what? Energy of what? Photon minus what? True of course, this will come here, right? Energy of photon minus what? This. So what we have? 7.88 minus 5.76. So that would give you what? So 7.88, 5.76. So 2 here, 1 and 2. So 2.12 electron volt. Can you see that calculation is very easy? Yes, option 1. A. That is the correct answer. Number 5 then. Number 5. I hope we are getting this class. I hope the God is, the light is set. Okay. Now, he said, ultraviolet light. This is a very simple question. Ultraviolet light has a wavelength of 400 nanometer. 400 what? Nanometer. 400 nanometer. So, ultraviolet light has a wavelength. Wavelength represented by lambda. 400 nanometer. Please, nano. All of you know what nano is, right? 400 times what? 10 power what? Minus 9 meters. So that will give you 4 times 10 power. This 2 0. Factor it here. What do you have? That will be minus 9 plus 2, right? So that is minus 7. Please take note of this. I always take the video back. Alright? So if the speed of the light in air is always what? 3 times 10 power 8 meters per second, right? So the frequency of the ultraviolet light, so that's for frequency, of course. You know that what? Speed is equal to air lambda, two of us. This is a very simple question, right? It's just mathematics, okay? So air equal to what? C over lambda. So C means speed of light, okay? So the speed of light is 3 times 10 power 8, alright, over lambda, which is what? 4 times 10 power what? Minus 7. So what do we have? 3 over 4 is just like 7.75, right? Times. Now, how do you solve this? Mr. Green, what is that answer? These are the things you need to know. 3 over 4 is 3 quarters. 3 quarters is 0.75. Just put it down. Then this is 8, right? This is minus 7. When minus 7 goes up, according to it, this becomes what? 8 plus 7. It was minus. Once it lands on the becomes plus 7. Mr. Green, why don't you press calculator? Why are you using mathematics? You know that your calculator might really be what? You know? Before you use your mouse to be pressing your calculator, someone would have already, quickly get the answer. So, what we have, move this one to this side, that would be 7.5, right? So we have 8 plus 7, 15. Then this one that you move forward, that would be minus 1, right? So that's what? 10 times 10 is power 15 minus 1. That's what? 7.5 times 10 is power what? 14 what? Liter. Because you need 2 questions. Oh, sorry, 2 questions. Hard. Can we see that beautiful answer? Alright, so let's move to the next one. This one is also calculation. I think I can wipe this off, or should I just wipe this page off? This page is okay, right? Okay, let me just wipe this one off. I believe that you can play back the video to get your question back. This is so wasteful. So now,
Mr. Brain,
yes,
with velocity at the speed of light.
you have to talk loud so that your people can capture your voice. Otherwise, you keep quiet. I don't want to question.
The speed of light is 3 times 10 to the power 8 meter per second.
Yes.
Yes, so you go minus
8, please. 8. Thank you. Alright, now, let's continue. So, number 6, the energy associated with an X-ray of wavelength 9.0 times 10 to the power what? Minus 10 meter is. So, what will be the energy of something that has a wavelength of 9.0 times 10 to the power minus 10 meter? That's what they are saying. This is X-ray. What is the energy associated with it? So, energy at atomic level is always that constant times the frequency, right? So now, look at it. Frequency was not given, okay? So, come back to this formula of F lambda, right? Come back to this formula and make frequency summation formula, okay? Why? Because frequency was not given. This is all we have, right? This is all we have. We have this, we have constant, and we have velocity. So we don't have frequency. So we cannot use frequency. We have to substitute to the ones we have, which is what speed of light and wavelength. So if I make frequency summation formula, I end up having what? Speed of light over what? Speed of light over lambda. So now, if you put it in this equation, what we have? Planck constant times what? Speed of light over lambda. Let's put that and get our answer. So Planck constant is what? That one is only 6.6. Please don't forget, I tell you minus 34. Times 6 is what? This is something you always remember. It's what? 3 times 10 to the power 8 over the wavelength they give you is what? 9 times 10 to the power minus 10. Mr. Play, let's take calculation. No. Just do this to sharp, don't waste time. 3 here is 3. 3 here is 1. 3 here is 1. Look at 6.2. So 3 here will have be 2.2. Can you see that? Very quickly. So my answer is what? 2.2 times 10 to the power 9. I have minus 34. I have plus 8. And this minus 10, when you go up, you become plus 10, right? So this is 1834. You can do your mathematics. What's the answer?
Minus 16.
Thank you very much. Minus 16 what? Minus 16 joules, right? Energy. Joules, thank you. So option what is that? Huh? B, right? Thank you very much. So now number 7. Number 7. Now I want to clean something I just wrote down. Oh my god, I am just catching. I hope we are getting the class.
Yes, sir.
So, number 7, the threshold frequency for a metal surface is 3.0 times 10 over 14 hertz. Full stop. If, I mean, you know that guy, that is, that Facebook guy, what is his name? That guy. Alright, let's continue, don't mind me. So, we have metal surface threshold frequency F naught. F naught is what? 3.0 times 10 to the power 14 hertz. If Planck constant, that one is constant, 6.6 times 10 to the power what? Minus 34. Minus 34 what? 2 seconds. The work function of the surface. Can you imagine? This is a simple question. Work function. So work function is simply what? Planck constant times what? Times what? Threshold frequency, please. So that will be what?
Threshold.
Threshold frequency, that will be what? 3 times 10 to the power what? 14 times 6.6 times 10 to the power what? Minus 34. What is simple question? Alright, now 3 times 6 is what? 18, right? 8 times 1. Put your decimal. 3 times 6 is 18 plus 1 is 19. Can you see that? Times 10 to the power what? Now 14, that what? 14 and minus 34. What would that give you? 20, right? Minus 20 again. So move this one forward. Back. You move this one forward. If you move this one forward, the answer will have 1.98 times 10 to the power. You are going to add 1 here. When you move backward, is it backward or forward? It is backward. When you move backward like this, you are adding 1. So add 1 to this minus 20 and minus 19 what? Joules of energy. Okay? Now the last question is for you to solve, alright? So let's read the last question, then I'll leave it for you to solve. It said, a metal has a work function of what? 4.4 times 10 minus 19. If the speed of light is what? In vacuum is what? 3 times 10 per what? 8 meters per second. And the Planck constant is what? 6.6 times 10 per what? Minus 34. The wavelength of the threshold frequency is now. I'm looking for wavelength of the threshold frequency. This is your question to solve. Drop your answer in my chat box. Thank you. Let's start another class.